is the video solution of Advanced Data Analysis exam 5 practical part. Okay, first of all, you need to go to UBZ01FST. I deliberately include this part in the video because I am really sick of people who cannot access this directory. So, this is the path for you. Okay, since I am outside the network, I have also digit extra information. You will arrive here. Okay, it's not exams, it's courses. Okay, then you go to exam colletti, exam colletti, not course colletti, exam colletti. Okay, and then you find yourself. Okay, and you copy all the content to your desktop. Oh, it's a good idea in case your desktop is a complete mess to build a separate directory inside your desktop and copy the things into this separate directory. Okay. In the meantime, we can turn MySQL, HideSQL on. This is my desktop, but this is the separate directory into my desktop. I have here HideSQL as you should have. Okay, I turn it on. Okay, you on Alco, open my login name, my password. In the meantime, let's see whether it has. I'm connected from outside, so it takes a lot of time. Do it exam, it takes some instance. Okay, let's see what exam is about. You will see the picture, you will recognize it. It's a part of Sakila database, so I suggest you here to use Sakila free, or here finally the file. This exam contains a single file, so you take it and copy it here. No, not on Heidi, but on my desktop. So I copy it here. I don't see why a text file could be harmful to my computer. Okay, now it's copied. Okay, it suggests to use Sakila free. Okay, first of all, we have to build a query which counts for each store how many active customers exist. So you will see that you have a table stores, a table customer. Each customer has a store ID, which is a store of reference. Okay, and so you just need to take these two tables. Okay, finally Sakila has arrived. Okay, so we select Sakila free. Just one click and you will see the V. Okay, it's not necessary to make a double click, otherwise it will appear in the query window. Okay, switch to query. So I just click here to see which tables I have available. Select. I don't write right now what I'm selecting. So from customer in join store on customer dot store ID equal store dot store ID. Okay, now which fields counts for each store how many active customers exist. So we have to take into consideration only the active customer, so I would make a where customer dot active. Okay, this is a tiny int, so it's not a boolean. Why it's written boolean here? Okay, it's tiny int here. If you click on customer, you will see that active is tiny int, so equal 1. I have to count, so I will have to group by store. Group store ID, and I have to count the customer, so the customer ID. So count. You can count the records or the customer ID. It's exactly the same for each store. So I would like to see also store ID. Okay, let's see the result. Result is displayed here. 218 and 366. Okay. Just to check, let's see what happens if you, instead of customer active equal 1, write customer active equal true. Okay, it should work anyway. Let's see. Yes, it works anyway. Okay, I save just to avoid losing it. It's on my desktop. I build another desktop. Okay, let's see. I have to save with sakila.sql. Okay. Create a view called as your surname, which displays the list of customers whose last name starts with the same letter as your last name, together with a full address. So, select. So it's a list of customers, so just from customer. Together with a full address, so I need to take things from address, city and country, because I need also the city and country. So from customer inner join address on customer dot address ID equal address dot address ID inner join. Many times here I put parentheses just to make things clear, but honestly not necessary. City on address dot city ID equal city dot city ID in join country on city dot country ID equal country dot country ID. Okay, now what do I have to select? Display the list of customers whose last name starts with the same letter as my last name. So here I'm not finished. Where customer dot last name like C. Okay, and I have to display first name. So in this case it's much better to select them from here. First name, comma, last name, comma, address. So these are columns in address. Address, comma, address 2, comma, postal code, comma, city and country. So these are columns from city and country from table country. Okay, let's make things clear. Let's see whether it works. Run only the selection, otherwise we'll rerun the first one. Okay, last names, only people with my last name. Seems to work. Okay, it is the key, however, to create a view. So create view Coletti as. Okay, now I can execute this only once, because once the view is created, let's see, I refresh now. Okay, let's see whether is it my. Okay, maybe it's here. Okay, I also save. It's a good idea. Yes, I will overwrite it. Build a new table called as table surname, where surname is your last name, to contain data on food sold to customers. Fields are barcode, name, description, unit in stock, price. Possible record examples are... Oh, remember that here you don't need to put a record example, just a field. Okay, you can create it in two ways, honestly. Either manually or automatically with a new table. Let's see if we have new table somewhere. Tools, file, here. Do we have new table? Database Sakila. Create a new table. Probably it's much better to create it using the graphical interface. So, oops, my graphical interface is not responding. So to be create table colletti, I have field barcode, which is, if you look, it's 8, 10, 12, char 13, or if you don't trust that the barcode can have only okay, add column 1 barcode, it's a char 13. Well, not null, please. Okay, add the second field is name. Well, clearly name is voucher 50, it's okay. The third field is description. Description is a long text, so text, add units in stock, which is clearly a int. And finally price, which is we'll say a decimal. How much? 5,2. Okay. Barcode, it's the primary key. So indexes. If you do it with a graphical interface, setting a primary key, it's not extremely easy. Okay, because you must find it. Okay, I think we have everything. Allow null, if you want you can allow null description. Okay. Well, you can flag this to unsigned, but it's not something we've done in class. Okay, I think we have done everything. Now you click on save, if it works. As usual, my graphical interface is stuck. Oh, the alternative would be to write the code manually, following the slides. You can also do it with a graphical interface. Look what it's doing here, and in case, adjust your code manually. Okay, when you finish, you have to return to sakila.sql. Okay, in case you feel that you had problems, you can return also the log, which is this part here. Okay, you can see here the code for creating the table. But if you want, you can copy and paste it here. If you want to modify it slightly, you can copy and paste here. Or if you want to check it personally, let's say, well, I will say everything is done perfectly, apart these things that we have never seen, but it's not something we should worry about. Okay, it's not mandatory to copy the code here. You can also avoid it. I will look directly at the database whether you have created the table correctly or not. In any case, now save. Okay, and you can shut down Sakila. Okay. Now we switch to the second part. The exercise on R. Here I have R portable. If you want, you can use the installed R. My R portable is already configured in the right way with all the packages installed in the right way. So load package, R commander. Okay, build a new factor F containing this. There is no, here I don't ask you to load any workspace. So you just change the working directory to your, okay, new factor f, so f is a factor containing these text values, so c of a, b, c, abc, abc. So I just copy and paste because close all the parentheses. So I put some space just for readability. Let's see. Okay, I don't trust myself, so I check. Okay, display its levels only. Okay, build a new vector G containing numbers from 1 to 20 and then from 19 to 1. Well, this is extremely easy. I don't trust myself as usual. Okay. Modify vector G, replacing automatically all the values larger than 15 with 0. So G is equal to G. No, so I have to take G, alt values larger than 15, and set them equal to 0. You can write it also with okay, so I have 0 going inside G with all the values larger than 15. Okay, no, this parenthesis is curl squared. Okay, you can do it in many other ways. This, if you really want, you can even use a for loop with an if inside. It's not difficult. This is probably the fastest way, and since I don't trust myself, let's look at G. Okay. It's a good idea to save now. Save script as exam.r. Save. I also saved the workspace. exam.rdata. Okay. Using an appropriate loop, calculate this quantity and put the result into H. Okay, so I have to build a loop of going from 1 to 25. It's written, so for j in 1 to 25. Okay. First of all, I set h equal to 0, just to be sure. Now, h is equal to the previous value of h plus 2 to the power of j divided by j plus 3 to the power of j divided by j squared. Okay, if you are sure about the order in which mathematical operations are performed, you can write it in this way. If you are unsure, you can put as many parentheses as you want. It's not forbidden. So, for example, this amount of parentheses, just to be sure that you perform the power operation before the divisions. Okay. Well, I hope that you know that division is always performed before the addition. Okay, it's over. And let's see. Okay, result is correct. Okay, now load dataset. Well, just to be sure, I save again. Load dataset CO2 from package dataset. Okay. Create an appropriate graph to display variables conc and plant. Well, it's a usual dataset, you should know it. So variable, in any case, variable plant is a nominal variable, and variable conc is a scale variable. It's evident. So graph, it's a box plot. Conc plot by groups. plant. Okay. Well, it's very similar. Doesn't seem to be any difference. Okay, in any case I close it. Create a pie chart for variable plant using colors red, white, yellow. So graphs, pie chart for variable plant. Okay. Okay. As you can see, it's using all the possible colors except for red, white, and yellow. So we have to tell it. Okay, here instead of rainbow color, 1, 2, 3, 1, 2, 3. Okay. You explicitly write the colors. R should be able to interpret your red, white, and yellow as the appropriate colors. Yes. Create a new dataset CO2B containing data from CO2, excluding those cases with variable treatment equal to chilled. Pay attention, excluding, So, data, manage variables, active dataset, subset active dataset, include all variables, subset expression, treatment, must be different. I don't remember what is different here, probably this one from chilled. Okay, dataset CO2B. Okay, let's see. Do I have any chilled? No, all non-chilled. Okay, perfect. I save. Import file medicines.txt into dataset medicines. So we have to import a new file. So okay, dataset is called medicines. There are some questions here, and the text does not answer. So we go back and we take a look at the original file. Okay, you can see there are headers in the first row, and it's evidently a tab delimited file. So there are headers in the first row. There are no missing data. It's in the local system. The field separator are tab, and there are commas separating the decimal numbers. Okay, I close it because I don't want to have problems. Okay, I select medicines. Okay, I don't trust myself, so I take a look at it. Yes, it seems to have been imported correctly. Okay, yes. I save. I also save the workspace. Okay. Suppose an economic quantity grows with a rule blah blah blah. So you should read the rule carefully. Build function reaches, which receives as input a number t and returns a number indicating for which quantity, for which index the quantity reached at indicates which quantity, returns a number indicating which quantity is reached at iteration t. Okay, so reaches function receives an input number t. Okay, and now we must. So what should it do? It should simply go on with a sequence and until it reaches t. So first of all, we start by setting q equal to 1 and small t equal to 0. Okay, now we go on with the sequence. So for t in 1 up to big T, okay, the new q is equal to the old q plus 1.5 to the power of small t. Okay, and now return q. Okay, we have everything. I think this is the starting, exactly as the text. Then we will make this sequence, we'll go through this sequence up to big T, and the new q is equal to old q plus 1.5 to the power of t. Okay, let's see. Okay, no error. Let's try. First of all, reaches of 1 should give me... What should it give me? Reaches of 1 should give me 2.5. It's written here. 2.5. Reaches of 2 should give me 4.75. It's written here. 4.75. Okay, just to test it, reaches of 20. Okay, a large number. Okay, finish. We save everything. I save the script. I save the workspace. Okay, I check that it has been saved. Okay, I shut down everything. No, I have already saved. No, it's not interesting. No, it's not interesting. Okay, I now check that I have everything. XML data. Well, medicine is the old file and sakila.sql. Now, if you have been smart, you would have left the old window open so that you don't have to retype ubz01fst, and you just drag the files. Oh, these are the 3 files that you have to drag. If you include also medicines, it's not a problem, but remember that you will have to overwrite or not overwrite the old file. It's the same. Okay, but don't create copies, please. Okay. So the old medicine stays here. Okay, and your exam is over.